What is correlation? Correlation is gotten from two words which are co, meaning together. So of course, by co, you already know that we are not talking about only one thing. That is, it is not univariate. And relation. Relation, of course, means are they related? Is there a relationship between them? So you're talking about, is there a relationship between two or more things? So, and of course, from the name the name already suggests that we'll be dealing with a bivariate data. And the bivariate data is a data that has two variables. Alright. Now, what correlation does? What is correlation? What is correlation? Correlation is a statistical method of analyzing or deriving a statistical method of stating whether there is a relationship between two variables, to detect whether there is actually a relationship between two variables. So correlation answers questions like, are these two variables related? Are they related? And what is the strength? What is the strength? Are they related? And if they are related, what is the strength of that relationship? Now, it also tells us about the direction of their relationship. So you can use correlation to test for if two variables are related. In the sense that, for example, if we could use students studying hours. For example, if a student study for 2 hours to a student studying, compared to a student studying for 3 hours, compared to one studying for 1 hour, another studying for 4 hours, and their exam scores. So, for example, this one have a particular exam score. Each of them will have a particular exam score. So, we want to know if their exam score is related to their studying hours. Another thing is to know if the height of students is related to height of persons, or maybe height of any experimental unit is related to their weight. For example, if I measure the standard length of fish and measure their weight, we want to know if they are related. So, for example, if they are related, we could try to estimate that, okay, the longer the fish, the higher the weight. That is if they are actually related. So, and that's what characterizes correlation. So that there are two characteristics of correlation, or three characteristics of correlation, which are positive correlation and negative correlation and no correlation. So these are the characteristics of correlation. So, for example, as I was saying, the longer the fish, the higher the weight. That is to tell that if this variable increases, the longer the fish, then the more the weight. So you see they are in the same direction. Or if I say that the longer the fish, the slower its speed. So, for example, if the longer the fish, the heavier so this is like weight and speed. So, like the heavier the fish, the slower its speed. So you see the directions are different, right? So this one tells us that it is a positive correlation. A positive correlation is one that as one of the variable increases, the other variable decreases. And mind you, there are two types of variable. We have the dependent and the independent variable. The dependent variable and the independent variable. What is a dependent variable? The dependent variable is the variable that we are trying to estimate by getting the variable by using this independent variable. So this variable tells us, or this variable explains this variable. So this variable is dependent on the value of this variable. So this independent variable is usually x in mathematics, and this one is usually y. Alright, so what we are talking about is that in positive correlation, for example, height being x and this guy being y, if as the variable x increases, y increases, then it is a positive correlation. The first variable increases together with the second, or if it decreases and then this one too decreases. Alright, then the negative correlation is when as one increases, the other decreases. So an example of this one is this height and weight I talked about. An example of this one is like all things being equal. This one, as your study hour increases, we assume that your score should also increase in exam. Alright, so this is a positive variation. Alright, but in a negative variation is, for example, the demand curve. So that as your price increases, the quantity demanded is what? Decreases. So since quantity demanded decreases as price increases, then it is going to be a negative correlation. So as one variable increases, the other decreases. So that is a negative correlation. Then no correlation at all is when there is no relationship between the two variables. So for example, the number of years I spend on earth and how successful I will be, they are unrelated. They are unrelated. So I said no correlation means that there is no relationship between those two variables at all. Now please, I want to enjoin you to do something. Make sure to watch this video from beginning to the end. I am going to be showing you either in this video or the second video about correlation. Correlation is actually related with another topic called regression. So we're going to do correlation and regression. Now, I will enjoy you to watch the video from the beginning to the end because somewhere within the video, I am either this video or the second video, I am going to show you a trick that you can use to verify your answer. Now, I said that this variable x increases, this one increases positive, the one increase, the other decrease negative, this one no correlation at all, no relationship at all, then that is no correlation. Alright, so if two variables are related, we say they are correlated. So they can either be positively correlated or negatively correlated. Now, we have talked about the dependent variable and the independent variable, alright? So the next thing we have to talk about that is related to correlation is the scatter plot. The scatter plot. You see, the scatter plot and regression are related. You see, the scatter plot is a plot that shows the set of the data set that has been plotted on a graph. It's a graphical representation of our data. That is the scatter plot. The reason why it is called scatter plot is that it takes the form, it takes something like this form. So look at a plot like this. You see it is scattered because the values are not regular on a particular line. When we will be doing regression analysis, I'm going to show you, I'm going to be showing you the straight line equation. For example, look at this. If I were to plot a straight line graph, I am going to have something like this, such that every data lie on one point on the line. So, but in a scatter plot, all the data are not regularly on the line. So that is why we need a regression line to keep the least square difference between the data set. I'm going to explain that in regression analysis. So, a scatter plot is what we can also use to check if there is a correlation between the set of data. So, for example, look at this data set. How do you think they are related? If you notice, these data sets are more regressed in this direction, like this. So, what do? You check, you are going to draw a line that can fit. It's called the line of best fit, and that's the regression line. That's the regression line. So that line shows that okay, the relationship is in the is an inverse relationship. Inverse relationship, that is, it is a negative correlation. An inverse relationship. But what if the data plot, the scatter plot, was something like this? This would be what? A positive correlation. Why? Because the slope is in this direction, is in the positive direction. Like this would be like demand curve, supply curve. So you see that the slope is in the positive direction. So that would be a positive correlation, and this would be a negative correlation. Now, what if the plot were to be like this? For example, this. You can see that there is no actual direction in which all the data sets are taken. So this is going to be what? A no correlation scatter plot. So it means that there is no actual relationship between the variables y and x. In this variable, you can see that as x is increasing, y is also following it to increase. Is increasing in the direction of x. This is decreasing in the direction of x. So that's why there is a relationship between them. Here, there is no relationship. So that's what a scatter plot is. Now, what we are going to do is to get what is called the correlation coefficient. It is the value. Let's discuss the correlation coefficient. Correlation coefficient. Correlation coefficient is a particular value that we can use to dictate the type of relationship that exists between them, or the characteristics of the relationship that exists between them, or the correlation that exists between the variables, or the strength of that relationship, or the direction of that relationship. All right, I'm going to discuss that. Now let's discuss that in details. I said this correlation coefficient is denoted by R or rho. Is a value that helps us to get the characteristics of the relationship or correlation that exists between two variables and the strength of that relationship, or even the direction. All right. So our correlation coefficient is given by a particular formula. So this formula is according to Pearson. So Pearson's correlation coefficient. Pearson. Now, please go down in the description to click on the video where I proved this formula. There are two formulas that are exactly the same. All right. So this formula, Pearson's correlation coefficient. So first, let's discuss more on this correlation coefficient. The values it can take range from positive 1, negative 1 to positive 1. From negative 1 to positive 1. So you can have 0 in between. 0 will mean that there is no correlation. 0 will mean that there is no correlation. And negative 1 will mean negative correlation, while positive 1 will mean positive correlation. So the more your value tends towards 1, the stronger the relationship. And the more your value tends towards 1, the weaker towards 0 rather, the weaker the relationship. So you can tend towards, please let's listen. I'm going to take that again. I said the more your value tends towards +1 or -1, the stronger the relationship. But the more your value tends towards 0 on both sides, from both sides, the more it tends towards 0, the weaker the relationship. So for example, if you have if you have a correlation coefficient value of R equals like 0.1, for example, let's say 0.5, or let's say 0.3, for example, 0.3. From 0.3, from 0.1, 0.2, 0.3, 0.4, 0.5, even let's just say 0.1 to 0.4 is going to be a weak positive correlation. Now it's positive because there is positive here. Now, if it was a minus this, it would be a weak negative correlation. And it was a minus 0.9, minus 0.8, minus 0.7, minus 0.6, minus 0.5. It's going to be a strong negative correlation, and of course, an R value of 0.9, R value of 0.8 is going to be a strong positive correlation. So the more you tend towards 0, the weaker the relationship, and the more you tend towards the two ends, negative and positive ends, the stronger the relationship. All right. Now, what is the formula for this correlation coefficient? So we have established the values of correlation coefficients. For this formula of correlation, please, I will enjoin you to go and watch the video where I proved these two formulas. I'm going to be giving you two formulas for the correlation coefficients, and those two formulas are the same depending on the method you want to use. All right. So the formula for correlation coefficients, or rho, is going to be summation of x minus x bar, y minus y bar, all over summation, the square root of the summation of x minus x bar, y minus y bar. All right, and all squared, because it's going to be the standard deviation. So we are taking the standard deviation. You can use sigma or s to represent that. So this one's represent the standard deviation of both x and y. All right, so the second formula is, you can say rho is equal to summation x y minus summation x summation y, all over the square root of n summation x squared minus summation x all squared close bracket, y n, you're just going to copy this and change it to y. And as in copy the same thing, but change x to y. So n summation y squared minus summation y all squared. Alright, so these are the two formulas for correlation coefficient. And how do you compute this? Remember when you want to do statistics, that you want to compute the standard deviation, that you first do x, and then next you do the mean, take the mean of x, and then you take deviation from the mean, and then square of deviation from the mean. And sometimes you can even take the what's called the standard value or whatever for the mean, then you square it and all of that. So it is the same approach that you apply to this using the first equation. You will prepare a table for both x and y. Then in the next table you will have the deviation from the mean for each value. Then so the summation of that deviation, you take the deviation from x, deviation of each x value from the mean of x, and deviation of each y value from the mean of y. So after taking y, you calculate the mean of y somewhere here. You now take the deviation of each guy from the mean of y. Then after taking the deviation of this from x, deviation of y from y bar, then the next thing you do is take the, multiply x, these deviations, multiply these deviations from by themselves. Multiply this deviation of x by the deviation of y. So you are going to take this y minus y bar times x minus x bar. So you see, you are preparing a different table totally. You are not taking each value here and then bringing it. No, you are creating a separate table for the summation, the deviation of each guy of each x value from mean, and deviation of each y value from mean. You are first taking those, then you now multiply each value. You get, let's say you got 2 here minus 3 here. You multiply that, you get minus 6. Do you understand? So you now take the summation. So it is the summation that you take here. When you add every of the value here, the answer you get, let's say you got 29, is what you plug in here, 29, over. Then after taking this, the next thing you take is the square of this one. So that will be x minus x bar all squared. So the value here, you square, that will be 4. Then you also take for y as well, y minus y bar all squared. You square that to minus 3 squared equals 9. Then you take the summation. So when you take the summation, let's say you get something like 13. So you come here, summation of 13. And summation, okay, this is also summation of this. There's going to be a summation here. That will be summation y minus y bar all squared. So you are going to take the summation of that, and you will now multiply it by the summation of this. Let's say you got like 12 here times 12, then you now divide. And that is how you get your correlation coefficient. So let's take one example. This question says the quantitative and aptitude tests of 10 job seekers are shown in the table below. So we want to see if the quantitative test and the aptitude test of job seekers, of particularly 10 job seekers, we want to see if the values are actually correlated. If the values are correlated. For example, this man scored 6 in quantitative test and had 5 here. This man scored 8 and had 6 here. This man scored 4 and had 3 here. This man had 7 and had 5 here. This man had 9 and had 7 here. This man had 10 and had 8 here. So we want to see if these values are actually correlated. Alright, so the first thing to do is write your formula again and see what you need in your table. So our formula for correlation coefficient, there are two formulas that we gave. We said is either you use summation of x minus x bar, y minus y bar, all over the square root of summation x minus x bar all squared, open bracket, y minus y bar all squared. And we said this formula is the same as, so you can, I'm going to be using the two formulas in this example. So you see, you can also use the formula summation y minus summation x and summation y summation x and summation y all over summation. Now there's a trick to actually getting your value here. I'm going to be showing you the trick, but we're going to be solving this first. So we have n summation x minus this is summation x squared minus summation x all squared. Then that's close bracket here. There's an n here. Close bracket. Summation x summation y. Just repeat the same thing. Only exchange x for y. Okay. So this is what we have for our formula. So we're going to be using calculator to. Now we will need. All you have to do. So I obtained 241 for my sum of squares for, sum of the y square, 241, okay? Then, so I have gotten all that I need. All I need to do is slot in my values inside the equation. N is 10, so we have 10 times summation of xy. The summation of xy was 313 minus the summation of x. That is 59 times the summation of y, which is 45, all over n again, times the square root now. So we can split the square root into 2. The square root of 10 times what is summation of x squared? 417 minus summation of x all squared. So summation of x all squared. Take note, it's the summation of x, not summation of x squared again. Or summation of x, which is 59, then square that 59. Then times the n, 10 times summation of y squared, 241, and minus summation y squared, that is 45, all squared. Alright, so I'm going to machine this. Here I have 3130 minus all over. Okay, let me quickly solve that. So at the end of the day, I have this by this by this, and then I take this times this to give me this, and square of this by this, the square of this 2025, and then this minus this 475. Then after subtracting this, I have this. Subtracting this, I have this. So the square root of this is this, and the square root of this is this. So after multiplying them, I have 515. 475 over 515. So if you look at it, you see that they are even very close to each other. So it will tell you that there is a kind of strong relationship between them. Yes, you will know that by how close your values on the numerator and the denominator are, will tell you the kind of relationship you get. So eventually we have 0.9, approximately 0.9. So we now conclude that the variables x and y are strongly correlated. Strongly positively correlated. They are strongly positively correlated. Alright, so that's how to compute correlation using that first method. I'm going to use the second method in another video, and I'm going to, in that video, show you how to do the same value, the same thing to verify that your answer is correct using a particular trick. Thank you very much for watching this video. Please do well to subscribe. God bless you.